Okay guys, for 12.4 we're going to talk about angle measures and segment lengths. The first thing we're going to talk about is what we call an inscribed angle, alright? That's when the angle is on the circle. So you look over here at angle ABC, you notice that B is on the circle. Whenever that happens, we know the angle is equal to 1/2 of the arc. So let's say I told you that arc AC is 60, then you know that angle B would be half of that, so the answer would be 30, alright? For the next one, we're going to talk about the angles of a circle. So for that one, you notice angle 1 is inside of the circle. So for that one, but it's not at the center, and that's the key. For that one, we're going to use the formula, the angle equals 1/2 of arc 1 plus arc 2. Now, the reason that you could do that is if you think about it, guys, this arc and this arc create the angle because you have vertical angles. So wouldn't that angle be the same? Yeah, so we can use that formula to be able to solve for it. All right? Now, a secant is a line that intersects a circle at 2 points. For this one, we're going to talk about when the angle is outside of a circle. That's why we need to know what a secant is. So, looking at this angle, we're going to talk about angle 1, and we notice that it's outside of the circle. Whenever we do that, we know the angle is going to equal 1/2 of the far minus the near. So one way that I always tell students is to remember the TV show Inside Addition. Well, if you remember inside addition, then you would know outside you do the opposite, which is subtraction. So for this one, we would take 1/2 of whatever x is minus whatever y is. So you do x minus y, then cut it in half, all right? So let's try a few examples here at the bottom. It says, what is the value for each variable? So let's solve for x first. We notice that x is this angle right here, and it's on the inside. So we should automatically know we're going to use the formula for inside, which is that the angle, which is x, equals 1/2 of the two arcs it creates added together. So 90 plus 46, all right? So if I want to start solving that, I just go ahead and take 90 plus 46, and then I get 136, all right? And then go ahead and multiply that by 1/2, and we get that x equals 68 degrees, which tells us this is 68 degrees. Now, I have seen problems where they might ask for this angle right here. That's easy because you know that these two angles here form a straight line, so we would take 180 minus 68, and we would get 112 if they asked for that. Again, just be ready to see that. Now for this one, we notice that our angle is actually on the outside. So if we're doing outside, we always start with our angle. In this case, our angle is 20, equals 1/2 of far minus near. Our far angle is going, our far arc is 95, minus our near arc is z. All right, so if we want to go ahead and get rid of that 1/2, you can distribute it. I think the easiest way is to go ahead and multiply both sides by 2, so I get 40 equals 95 minus z. If I subtract 95, then I get negative 55 equals negative z, and go ahead and of course you know if you got negatives on both sides, they both become positive, so z equals 55. All right, hopefully that's pretty easy for you guys to understand, just remembering when to use inside, outside, or on the circle, okay? So for the next one, if two chords intersect in a circle, the product, which means we're gonna multiply, of the measures of their segments are equal, or congruent, of course, for geometry. So what that means is we're gonna take this small piece and multiply it by this small piece, and then take this small piece and multiply it by this small piece, and then set them equal to each other. So A times B equals C times D, all right? So let's go ahead and try that for this problem below. We know that we have 6.5 here, and we know that this piece is M. Be very careful with that to not put the 3 there. It's actually an M. So we're gonna take 6.5 and multiply it by M, and set that equal to 3, because that's this piece, times 7. All right, so we get 6.5m. We can't do anything with that yet. 3 times 7 is 21. Go ahead and divide both sides by 6.5, and you get that the answer is 3.2 when you round to the nearest tenth. All right. For the next one, we have two secant lines, which is our tweezers method. This is OW equals OW. What that stands for is outside times whole equals outside times whole. All right. So if I was to give this letters over here, let's put A, B, and then C, D here. We would go ahead and say we would take A, which is the outside piece right here, multiply it by the whole thing, which is A plus B, and then we're going to set that equal to the outside piece here, which is C times the whole thing, which is D plus C. All right. It's a little bit easier when you get to add the numbers in there, but overall shouldn't be too bad as long as you remember the formula. Let's go ahead and attempt this problem here. Now, there's a mistake on this problem that you're not going to see, so I'm going to go ahead and fix that now. What I'm going to do is I'm going to switch this and put the 3 out here and put the x in here. You guys can go ahead and do that on your paper now because it's going to make this problem more of what you're going to see, all right? So, first thing we need to do is we realize this is an outside times whole, right? So we're going to say OW equals OW. So we take the outside piece, which is 2, multiply it by the whole thing, which is 14. And then we're going to take the outside piece here, which is 3, and multiply it by the whole thing, which is 3 plus x. All right? So we can go ahead and take 2 times 14, and we get 28. Over here on the right side, we need to use the distributive property, so we get 9 plus 3x. Next step is we got to go ahead and take 28 and then subtract that 9 from it to move that 9 over. And we get 19 equals 3x. Go ahead and divide that by 3, and then you get that x equals 6.3 repeated. So we'll say 6.3 if we round to the nearest 10. All right? If you have one with the x on the outside, it's going to use a little bit of foiling and factoring and all that fun stuff that you did in Algebra 1, but you shouldn't see that. All right? All right, so for the last theorem we're going to talk about is still outside times whole equals outside times whole. I still use it that way. So OW equals OW. The only difference is if you notice this line right here, there's not an inside, so therefore you can't really do the whole the way that you want. They tell you to use outside times whole equals outside squared, same thing. And then, of course, you see that. So here's what I would do, is I would still use the outside times whole method. It's the same thing. It's just done. You just got to realize what's the outside, what's the whole. So let's start with the bottom line here. We know the outside is 8. Then we know this whole piece is going to be 8 plus 16, which is 24. Now, for this top piece here, we know that this is the outside, which is z. Then we're going to multiply that by the whole thing, which is actually still z. So it's like z squared, but I write it out that way to help me out. So next step is we take 8 and multiply it by 24, and we get 192 equals z squared. And then, of course, to get rid of a square, we take the square root of that 192, and we get 13.9 when we round to the nearest 10th. All right? So those are your notes for 12.4. Go ahead and make sure that you have them completed for next class.